Ask anyone about pi and they picture a circle. Diameter times pi equals circumference. Fair enough. But pi also appears in formulas with no circles in sight. Pendulum periods, random walks, even the bell curve. A circle constant should not be everywhere. Yet it is. Most guesses tie pi only to round objects, wheels, pizzas, planets. The math says pi measures anything that curves back on itself or rotates through angles. Once you think in radians, distance around a unit circle, pi becomes the natural unit of turning. Circles are just the first place you meet it. Ancient Egyptians estimated pi near 3.16. Archimedes trapped pi between two fractions by drawing polygons inside and outside a circle. More sides, tighter trap. He did not find every digit. He proved pi is a fixed ratio, not a guess that changes with the circle's size. Pi is defined as circumference divided by diameter. Big circle, small circle, same ratio. That ratio is irrational. Decimals never repeat, never end. But definition is only the front door. The deeper reason pi spreads is that circular rotation is baked into how waves, orbits, and angles behave. Degrees are arbitrary, 360 for a full turn. Radians measure turn by arc length on a unit circle. Half a turn, arc length pi. Full turn, 2 pi. When physics writes sine and cosine, it uses radians, and pi rides along in every oscillation formula you have ever seen. A grandfather clock swings back and forth. Its period, time per swing, involves 2 pi times the square root of length over gravity. No pizza in sight. The pi appears because the motion traces circular logic in phase space. Rotation math sneaks into back and forth motion. Drop a needle on lined paper. The probability it crosses a line involves pi. Throw thousands of needles, count crossings, and you can estimate pi without measuring any circle. Randomness and geometry link through the same constant. That is not coincidence, it is structure. The normal distribution, the famous bell curve, has a formula with pi in the denominator. Height times e to a negative square. No circles drawn, but integrating that curve around the entire axis uses pi. Whenever nature piles independent randomness, pi shows up in the total area. Here's the twist. Pi is not randomly sprinkled across formulas. It is the price of living in a world with smooth rotation and evenly spread randomness. Anytime you average angles, wrap distance around a cycle, or spread probability in two balanced directions, pi is the bookkeeping constant that makes totals come out right. GPS corrects satellite signals using equations with pi. MRI machines image your body with rotating fields built on sine and cosine. Engineers size pipes, gears, and antennas with circular geometry. Pi is not trivia, it is infrastructure hiding in plain sight. Recap: pi is circumference over diameter, same for every circle. Radians make it the language of rotation. It appears in pendulums, needle drops, and bell curves because those problems hide circular or rotational structure. Pi is everywhere because turning and spreading are everywhere. Pi hides in plain sight because nature loves cycles. Next time, how the Fibonacci sequence sneaks into sunflowers, shells, and pine cones without any plant doing algebra. Subscribe for weekly pattern hunts. This is Math Sketch.